Okay, so we will see chemical bonding now. Now, atoms combine with other atoms. It could be the same atom or a different atom. And why do they combine? Because they want to achieve a stable electronic configuration. Remember, we were talking about the queens or the kings of the elements, those that have a very stable configuration. So you can see here, so any element, wherever it is, so let's say it's element this one, so this element will want to lose 3 electrons to reach that level. Let's say this element will want to gain 1 electron to reach that level. So they want to reach a stable level, either by gaining electrons or by losing electrons, whichever is easiest for them. So they can gain electrons, lose electrons, or share electrons. Now, using this, you won't be able to see how they share electrons to be stable, but there is a possibility that if one lacks 2 electrons, then another can share 2 electrons so that they have 8 electrons in total in the outermost shell. We'll see that later on. For now, we're more concerned about gaining or losing electrons. Now, only electrons found in the outermost shells are involved in bonding. We never use electrons in the inner shells, nor we look at protons. It's only electrons in the outermost shell, and these are called the valence electrons. Okay, so valence electrons, so you see there's going to be a relationship with valency here. Okay, now there's 3 types of bonding. Ionic bonding, so this is where gaining and losing electrons will be involved. Covalent bonding, this is where sharing of electrons will be involved. And metallic bonding, here we're going to have just losing electrons. Okay, now for now we'll be concerned with ionic bonding. So you should be able to describe the formation of ionic bonds between group 1 and group 7 and ionic bond between metallic and non-metallic elements for the supplement. Now, ionic bonds are always formed between metals and non-metals. Now, ionic bonds means that there's going to be ions involved. Okay? That's why it's called ionic bonding. Now, why there are ions between metals and non-metals? Because we've seen that metals, so these ones, usually from 1 to, let's say, 3, these ones, they have a tendency of losing electron. Okay, so when they lose electron, they form positive ions, cations. And non-metals, they are the ones that are found over here. So these non-metals, they have tendency of gaining electrons. So they gain electrons. When they gain electrons, they become negatively charged and they form ions. So positive and negative charges, what happens? You have something that's positively charged and you have a particle that's negatively charged. Positive, negative, you have an attractive force. So this attractive force is called electrostatic force, which means that it brings them together. Positive particles, negative particles, they come together, they attract each other, and this is what makes the bonding. This is what brings them together. Just like when people are in love, they marry each other. So it's the love that brings them together. So here when we're looking at ions, it's the charge that is bringing them together. It's the electrostatic force. Okay? So an atom of the metal will lose its valence electrons. An atom of the non-metal is going to gain that electron lost by the metal. So metal and non-metal in contact with each other, so they will react. The metal lost by the metal, the electron lost by the metal will be gained by the non-metal. So there is a transfer of electrons. So metals say, Well, I have electrons in excess. I'm not going to use it. And non-metals say, well, I lack electrons, so give them to me. So there is transfer of electrons. So these are a few questions concerning ionic bonding. Before we look at ionic bonding, let's see chemical formula of ionic compounds. Okay, that's Form 3 content, and I'm just going to go through that again. These are the instructions. So you write the symbols of the element, the valency, simplify if possible, cross multiply, and write the formula. Number 1 is not written, same as we did in Form 3. Sodium, Na, chloride, Cl, sodium group 1 valency 1, chlorine group 7 valency 1. Remember, non-metals, the valency is equal to 8 minus the group number. Okay, cross multiply, you can't simplify here, so formula will be NaCl. Calcium fluoride contains calcium, fluorine, calcium valency 2 because it's in group 2, fluorine valency 1 because it is in group 7. It's a non-metal, so valency is 8 minus 7. Okay, you can't simplify, so I will cross multiply, so CaF2. That's the formula of calcium fluoride. Magnesium oxide O, magnesium group 2 valency 2, oxide is oxygen, group 6 valency 2, so 8 minus 6, that's 2. You can simplify, so I will simplify that. You can divide by 2. Simplify, you get MgO. MgO is the formula of magnesium oxide. Okay, so you're going to do for aluminum oxide, lithium nitride, calcium nitride. Nitride is nitrogen. Okay, so do that. I'm going to check your answers. Do that in your copybook. Now, the subscript number in a formula shows how many of the type of atom we have. For example, if you have Li2O, means there is 2 lithium and 1 oxygen. Here, it means there is 2 Na and 1 oxygen. Here it means there is 1 Ca and 2 Cl2 and 2 Cl. Okay, so the number subscript here means how many of it you have. Here you have 2 aluminium and 3 oxygen in that compound. Okay. So how does ionic bonding form? So ionic bonds are formed by the transfer of electrons from the metal that have extra to non-metal that lack electrons. And during the process, the metal will form a positively charged ion, and the non-metal will form a negatively charged ion. Oppositely charged ions will attract each other, forming ionic bonds. The higher the charges, the stronger the bonds and the stronger the forces of attraction. And the force of attraction is called electrostatic force. This is what I have explained at the beginning. Now, for your syllabus, you should be able to draw dot and cross diagram for ionic compounds. Before going through this, I want you to watch a short video.
We have previously learned about the formation of ions. Now we will learn about ionic bonds. Ions, as you already know, are formed from the loss or gain of electrons. Electrons, however, do not suddenly appear or disappear. They are, in fact, transferred from one atom to another. Let's look at sodium chloride as an example. Sodium loses one electron to form a sodium ion. The electron is not lost, but transferred to chlorine to form a chloride ion. So we have a sodium ion and a chloride ion. They are oppositely charged ions and will be electrostatically attracted to one another, much like how opposite poles of a magnet are attracted to one another. This electrostatic attraction is an ionic bond. Sodium chloride is an ionic compound because it is held intact by ionic bonds. The same thing happens with magnesium and oxygen. Why don't you grab a piece of paper and a pencil and draw the resulting ionic compound, magnesium oxide? Please pause the lesson and resume when you are done. Magnesium transfers its 2 valence electrons to oxygen, forming the magnesium ion and an oxide ion. The resulting ions are electrostatically attracted to one another, forming an ionic bond. Did you get this right? Did you remember to include the charges on the ion? Now, let's look at calcium and chlorine. Calcium loses 2 electrons to form a calcium ion. One of these electrons is transferred to a chlorine atom, and another is transferred to another chlorine atom, forming 2 chloride ions. The calcium ion is electrostatically attracted to the 2 chloride ions because the opposite charges must fully balance each other out. In all 3 examples, the resulting ionic compounds have an overall neutral charge because all charges are fully balanced out. In summary, an ionic bond is defined as the electrostatic attraction between oppositely charged ions. When an ionic compound is formed, the charges must be balanced so that the resulting ionic compound has an overall neutral charge.
So this video has summarized it, and try to make notes in your copybook based on this. The next video we're going to see in more details how you actually draw these ionic compounds. Okay.